Hey there, rocket enthusiasts, welcome back to the channel. Your home for all things space exploration. If you've been keeping tabs on SpaceX recently, you've probably witnessed something pretty alarming. We're talking about 2025, the year that was meant to be Starship's breakthrough moment. But instead of triumphant launches, we've been treated to a series of spectacular explosions that would make Michael Bay jealous. And when I say spectacular, I'm not exaggerating. Picture massive fireballs lighting up the sky, chunks of rocket debris scattered across the ocean, and, get this, actual pieces of spacecraft landing on someone's vehicle in the Caribbean. Yes, that really happened. So what's the deal with SpaceX? Why does their flagship rocket keep transforming into the most expensive light show on Earth today? We're going to unpack the technical breakdowns, the engineering nightmares, and the absolutely insane deadlines that are pushing Starship beyond its limits. Believe me, the reality is far more complicated than you might imagine. Let's jump right in. Before we go any further, let's bust a huge myth. Most of these dramatic explosions you're seeing, they're not random accidents. They're deliberate destructions, and there's a brilliant reason behind it. Every rocket that launches from US soil must be equipped with what's called a flight termination system, basically a remote-controlled self-destruct mechanism. Think of it as the ultimate emergency brake that mission control can activate when things start going sideways. And honestly, this might be one of the most ingenious safety protocols ever invented. Here's the logic: rocket trajectories are planned to fly over oceans. So if something fails, the wreckage won't come crashing down on anyone's head. But what happens when a rocket with active engines starts drifting toward populated areas? That's a nightmare scenario we absolutely cannot allow. The flight termination system prevents exactly that disaster. It blows up the rocket mid-flight before it becomes a threat to people on the ground. As an added benefit, it also burns off most of the dangerous liquid fuel before it can reach civilization. So when you see those incredible Starship debris streaks painting the sky, and they truly are incredible, it's typically not because the rocket spontaneously combusted. Something already went wrong, leaving the rocket intact but flying erratically. That's when mission control presses the big red button to destroy the vehicle and ensure all the pieces land safely in the ocean. But here's the key point. Starship isn't destroying itself for entertainment. It only self-destructs after something has already gone catastrophically wrong. And throughout Starship's 9 test flights, we've witnessed a remarkably diverse array of failures. Let me walk you through some of the most memorable moments, if we can call them that. During the inaugural launch, the rocket unexpectedly generated this enormous debris cloud, like a concrete hurricane, that helped send it spinning wildly out of control. That was absolutely insane to watch. SpaceX actually managed to fix many of those initial problems with Block 1 and saw some genuine progress. But then they moved to Block 2 and everything started falling apart again. Big time. The company has been fighting to recreate its earlier successes with the updated version. During test flights in January and March, the rockets lost control within minutes of liftoff, spreading debris across the ocean, and in at least one instance, debris actually crashed into a car in the Turks and Caicos Islands. Can you imagine that insurance claim? So what's behind all these catastrophic failures? Let's dive into the technical specifics, because they're genuinely mind-blowing. SpaceX engineers figured out that the January disaster was probably triggered by intense vibrations that created fuel leaks and fires in the engine bay. These vibrations might have matched the vehicle's natural resonant frequency, which amplified the shaking far beyond anything engineers had predicted. That led to premature engine failures. And once you start losing engines, everything goes to hell rapidly. The March test ended similarly, but investigators traced this failure to a completely different root cause, a hardware malfunction in one of the engines. So we're not just looking at one isolated problem here, we're dealing with multiple, interconnected engineering nightmares all happening simultaneously. During last month's test, the rocket actually nailed its ascent phase. For a brief moment, it seemed like SpaceX had solved the issues that had been destroying earlier attempts. But then, right after the Raptor engine shut down, a fuel leak sent the ship tumbling helplessly through space. This meant it couldn't perform a controlled re-entry, which was essential for testing a new generation of heat shield technology. So tantalizingly close, yet so devastatingly far. And then we had the most recent incident, which was arguably the most troubling of all. A Starship prototype, Ship 36, exploded before it even got the chance to leave the launch pad. This explosion occurred while SpaceX was filling it with super-cooled methane and liquid oxygen for what's called a static fire test. Fortunately, the area around the test site had been cleared beforehand, and all personnel were safe. Initial investigations point to a failure in something called a nitrogen composite overwrapped pressure vessel. That's a COPV for short. This component apparently failed below its proof pressure and under conditions that shouldn't have damaged the tank. Elon Musk responded to this incident on Twitter, pointing out that if further investigation confirms this is what happened, it would be the first time ever for this specific design. That's not exactly confidence-inspiring when you're trying to build a dependable spacecraft. Many experts believe that design modifications introduced in Block 2 are a primary reason for Starship's recent catastrophes. The new version is slightly taller than the vehicles SpaceX flew in 2023 and 2024, and it includes some major engineering overhauls. The enhanced heat shield is engineered to better survive the brutal heat of atmospheric re-entry. To enable longer missions, SpaceX actually gave up some cargo space to increase the fuel tank capacity by 25%. That sounds brilliant in theory, but it's generated some unexpected complications. One of the most dramatic updates is the redesigned fuel delivery system. Instead of a single pipeline carrying methane fuel to the ship's 3 vacuum-optimized Raptor engines, Block 2 uses 4 separate pipelines, 3 dedicated methane feed lines, 1 for each engine, and a 4th for other systems. This enables much more precise control of pressure and fuel flow to each engine individually. While this precision can enhance efficiency and engine management, it also eliminates something called the multi-engine dampening effect that existed in earlier designs, and that modification might bring some serious unintended consequences. Longer and more isolated feed lines can increase the risk of something called pogo oscillations. These are a type of self-reinforcing vibration that has historically tormented liquid-fueled rockets. By isolating each engine on its own dedicated pipeline, SpaceX may have accidentally created conditions where pogo behavior, which was previously controlled by the shared system, can now develop and intensify. It's like the difference between 3 people trying to rock a boat together versus each person rocking their own section independently. Another theory is that in optimizing Starship for Block 2, SpaceX may have eliminated or lightened some structural components to reduce mass. The first generation of Starship wasn't built for maximum cargo capacity. Its primary objective was straightforward reach orbit and return safely. Block 1 was essentially a proof of concept, a version built to demonstrate that Starship could fly and potentially be reused. It was heavier than optimal, used earlier versions of the Raptor engines, and wasn't optimized for efficiency. Now with Block 2, SpaceX is trying to get much closer to the ambitious payload performance they envision for future missions. But here's the challenge: how do you scale up the vehicle, increase fuel capacity, and improve efficiency while still depending on the same 6 engines? One possibility is that SpaceX is being forced to eliminate every possible ounce of excess weight, pushing the engines closer to their operational limits during launch. The downside is that this makes the rocket more delicate and more susceptible to engine overheating, structural stress, and vibration, a combination that can easily trigger failure. Now, whether all of these setbacks qualify as failures depends on your viewpoint. This is engineering, where broken prototypes are often a necessary step toward a reliable design. What makes SpaceX's approach seem strange to many people is that it deviates from the traditional model of rocket development. Historically, space agencies like NASA and established aerospace companies like United Launch Alliance have moved slowly and carefully. They typically postpone live testing until they're confident the rocket will perform as expected. That remains true today, as we can see with NASA's Space Launch System, which has been in development for over a decade. Traditional programs are designed to avoid public failure. Their philosophy is to take as much time as necessary to ensure success. SpaceX, however, follows a completely different approach. The company embraces a high-speed, iterative process that learns from failure. This methodology has played a crucial role in its rapid advancement, allowing it to achieve milestones like the reusable Falcon 9 in a fraction of the time it has taken others. However, the downside is that this method results in frequent and very public failures, sometimes attracting criticism, especially regarding environmental impacts near the launch site. Even by SpaceX's own move fast and break things in standards, Starship's development has seemed particularly chaotic. The path to Falcon 9 reusability, for example, was much more gradual. SpaceX first focused on proving the rocket's basic performance, and only years later did it begin experimenting with recovering and reusing boosters. With Starship, SpaceX is attempting to solve nearly every challenge simultaneously. It's developing a brand new rocket with new engines and trying to make it fully reusable from day one. That is an extraordinarily difficult engineering problem. The Raptor engines that power Starship are a major part of that challenge. Each vehicle uses 33 of them, tightly packed and firing together, which creates a host of technical hurdles related to vibration, synchronization, and thermal management. Imagine trying to coordinate 33 high-performance engines, each generating massive amounts of thrust, all while managing fuel flow, temperature, vibration, and a dozen other variables. It's like conducting an orchestra where every musician is playing a different instrument at maximum volume. So why is SpaceX pushing so aggressively and so rapidly? The answer lies in Elon Musk's long-term vision. He is completely focused on getting to Mars, and he wants to do it soon. While it's theoretically possible to attempt a Mars mission using existing rockets like the Falcon 9, the sheer volume of equipment, cargo, and crew required makes that approach inefficient and extremely expensive. To make Mars missions even remotely feasible, both financially and logistically, you need to be able to transport massive payloads in a single launch. When SpaceX CEO Elon Musk spoke to employees at the company's South Texas facility in late May, he rekindled excitement for his long-standing dream to send humans to Mars. He outlined a bold, though uncertain, timeline. The next optimal launch window to Mars opens in late 2026, when the interplanetary travel time shortens from over a year to roughly 6 to 9 months. Musk said SpaceX aims to capitalize on that window by sending up to 5 uncrewed Starship vehicles, each loaded with cargo, to the Red Planet. But he was also pretty honest about the chances, suggesting there's only a 50-50 probability that even one Starship will reach Mars in 2026. And given recent challenges, those odds may have gotten even worse. Before that window arrives, SpaceX plans to unveil a significantly upgraded version of its launch system called Starship Block 3. This version of the 2-stage system, which includes the Starship upper stage and Super Heavy booster, will be larger and more powerful. Expanded propellant tanks and improved Raptor engines could increase its payload capacity to as much as 200 metric tons. These upgrades are intended to overcome the engineering obstacles currently blocking progress. The Block 3 system is expected to address key technical limitations of the current Starship iteration. Engineers are racing to resolve a host of problems, including engine reliability, structural vibrations, a fragile payload bay door, and the resilience of the ship's heat shield. Some people see the shift to Block 3 as a fresh start, but even a flawless suborbital test flight along the same trajectory used in previous missions won't be enough to prove readiness for Mars. One of the biggest challenges remains refueling in orbit. Despite Starship's larger fuel capacity, a trip to Mars requires even more propellant than the vehicle can carry at launch. To solve this, SpaceX plans to launch a series of tanker Starships filled with fuel and oxidizer. These tankers would dock with the Mars-bound Starship in low Earth orbit, topping it off before the long journey begins. However, in-space fuel transfer, especially between large spacecraft, has never been attempted before. We're talking about transferring hundreds of tons of cryogenic propellant in the vacuum of space. It's an incredibly complex engineering challenge that no one has ever solved. Another monumental obstacle is atmospheric re-entry on Mars. The Martian atmosphere, composed almost entirely of carbon dioxide, poses a unique and dangerous problem. As Starship slams into the thin air at interplanetary speeds, it compresses the gas in front of it, generating extreme temperatures. This process breaks down CO2 into carbon and oxygen. The released oxygen could then start to oxidize, or essentially burn, the spacecraft's heat shield. Musk has called this one of the toughest problems SpaceX must overcome. No one has ever developed a truly reusable orbital heat shield, as Musk said in May. That is extremely difficult to do. So where does this leave us? SpaceX is essentially trying to solve multiple impossible problems simultaneously while working under an incredibly aggressive timeline. They're developing new engines, new manufacturing techniques, new refueling systems, new heat shields, and new landing systems all at the same time. The recent explosions and failures aren't just random bad luck. They're symptoms of pushing the absolute boundaries of what's technically possible. Every failure teaches them something new. But it also highlights just how many variables they're trying to control. The 2026 Mars launch window is rapidly approaching, and based on current progress, it seems increasingly unlikely that SpaceX will be ready. But that doesn't mean they're giving up. This is a company that thrives on seemingly impossible challenges. The question isn't really whether SpaceX will eventually succeed. Their track record suggests they probably will. The question is how long it will take and how many more explosions we'll see along the way. So there you have it. Space enthusiasts. The real story behind why Starship keeps exploding. It's not incompetence or bad luck. It's the inevitable result of trying to revolutionize space travel while working under an impossibly aggressive timeline. SpaceX is essentially trying to compress decades of traditional aerospace development into just a few years. The explosions are the price of that ambition. What's your take? Are these failures just growing pains on the path to Mars, or signs that SpaceX is pushing too hard, too fast? Drop your thoughts in the comments. I read every single one and love hearing your perspectives. If you enjoyed this deep dive into Starship's technical challenges, smash that like button and hit subscribe. We're pushing toward 1,000 subscribers, and your support means everything to us. Ring that notification bell so you never miss our latest space content. The road to Mars is clearly going to be bumpier than anyone expected. But one thing's for sure, it's going to be one hell of a ride. Thanks for watching, and I'll see you in the next video. Keep reaching for the stars, space fans.